Hello everyone. I'm going to be presenting to you something that has been missing in corrective maintenance processes, a standard troubleshooting process. Lean Teams USA has coined the process, control isolation and repair, aimed at gaining back valuable production time. Most organizations using automation within the value stream struggle with long and ineffective repair cycle times. Maintenance technicians are typically stuck in a vicious repair cycle, diminishing valuable production time. Take note, and a key point here, there is no element of determining cause of failure. Let's look at an instance of an organization that was struggling with a loss of valuable production time because of an ineffective repair process. Viewing the total cycle time of past maintenance requests, they established a current state of arrival time, averaging 25 minutes, and repair time averaging 24 minutes. To understand the effectiveness of these repairs, they also gathered data on how many times a technician had to return to an original request. Finally, the maintenance team wanted to understand the investment in developing their technician team, so they gathered data on formal training sessions for the technicians. As a note, 2 years ago, the maintenance team had invested in establishing two key metrics: circuit logic and accompanying fault tree analysis, but they were never used. The maintenance team decided to focus their improvement resources at the process bottleneck, the cutting process. Key measures were taken: cycle time at 6 seconds and throughput was 10 units per minute. During a value stream mapping session, they identified the key parameters for the next step of adhering. As key project metrics, the team decided on measuring production time loss and units/product loss gathered from maintenance requests. They chose these metrics because they are aligned with the overall strategy of increasing capacity. For this presentation, we will look at an example of maintenance request that well represents the current situation of their repair cycle. The operator of the equipment has stopped production because the motor driving the cutter will not turn. The operator initiates the first maintenance request. Lost production time has now started. The maintenance tech arrives and starts troubleshooting by focusing on the symptom, the motor itself. Technician has no other information of what could be causing the downtime other than the maintenance request itself. The troubleshooting process being followed here is specific to this maintenance technician. There is no troubleshooting standard work. Machine is turned back to production after some repair validation. Here we see the results, which are close to the averages seen during the team's data collection stage. Production time loss of 50 minutes. Do not forget, this is the value stream's bottleneck. This downtime results in a production loss of 500 units. 1 hour after the repair, there is a second maintenance request for the same condition. Production is stopped again. After 30 minutes, the response time, the same technician arrives at the machine. The technician starts their individual troubleshooting process by checking the motor. Again, the symptom. This time, and by chance, notices the gauge sensor is misaligned. This is corrected, and after validation of the repair, the machine is turned back to production. As the previous repair, no root cause was determined. The impact on the business has now accumulated to 90 minutes of production time loss, resulting in a loss of 900 production units/products. To compound the losses, the next process step, adhering, is now out of whip, having to wait for cutting. Continuous improvement requires standard work as a base to improve from, a fundamental requirement. There was no root cause determined in either maintenance request. The root cause was not complex. The sensor would sometimes move because of vibration, and with some problem solving applied, this fault could have been easily eliminated. Let's look at the value of the two tools the maintenance team decided to invest in 2 years ago. The first tool is a schematic of the cutter motor circuit logic, basically how and why the motor works. This is a visual of how a key component functions through certain controls. Not shown here, what I like to do is add measuring points and what these measures should be when conditions are correct. Key component logic is provided by the OEM. The visual is not the provided drawings. The second tool that works in conjunction with the circuit logic schematic is a fault tree analysis of the cutter motor system. It provides us with how the components are logically connected and the frequency rates of failure for the key components. It would have been logical for the technician to start troubleshooting at the substrate gauge sensor, as aligning has the highest rate of failure. These frequency rates of failure are gathered after some time of entry into a maintenance database. The control, isolation, and repair method follows 5 simple steps during troubleshooting. Standard work for troubleshooting is set through training. For each of the main operating systems, usually the value-add functions, there is both a circuit diagram and an accompanying fault tree analysis. The technician uses these two tools to refresh their knowledge of the logical operation and then reviews the fault tree to determine where best to start their troubleshooting. Control, isolation, and repair has many business-related benefits. Capacity improvements of 30%, repair time reduction of 50%, redundant maintenance requests reduced to 1%, if not 0. Frequency of component failure is reduced by 60% because root causes are easily identified, and reduction of outside expert costs, which we haven't talked about, reduced by 50%. If you would like further information or training on this and other lean maintenance related topics, please go to our website at Lean Teams USA. Thank you.